Hello, my name is Sam Stokes. I'm currently taking ECE535, Electromechanical Design, taught by Dr. Greg Buckner during the summer session of 2014. For my demo project, I will be displaying an example of Lorentz's law of force. Lorentz's law of force can be expressed by the following equation. F equals charged particle times an electric field plus that charged particle times its velocity crossed with the magnetic field, where the first term is the electric force, the second term is the magnetic force, and the sum of the two gives the Lorentz force. For a current carrying wire in a magnetic field, the Lorentz force is expressed by the bottom equation, which says F equals the current times the integral of the length of the current carrying wire crossed with the magnetic field. The right-hand rule can be used to show the direction of a Lorentz force due to the orthogonal nature of the magnetic field, the current, and the force in relation to each other. Start by pointing your fingers in the direction of the magnetic field and your thumb in the direction of the current. Your palm then points in the direction of the Lorentz force. Alright, now we are ready to show the physical demonstration of Lorentz's law. All the materials for us are what we need. They include a copper wire, which will carry our current, a 1.5 D-cell battery, and neodymium magnets. Okay, I've now put our materials together so that the magnets are on the bottom. They're oriented so that the magnetic field is in the upward direction. The battery is in the middle with the magnet stuck to its negative terminal. On the positive terminal is a copper wire. Current will flow from the positive to negative terminals so that on this portion of the wire, current will flow to the left, magnetic field is up, so the force will be away from us. On this portion of the wire, current will flow to the right, magnetic field is still in the upward direction, so the force will be towards us. From a bird's eye view, this will make the copper want to spin in a clockwise direction. The most important parts of the wire are those that are horizontal as we see them now. The vertical portions will not feel a Lorentz force. So let's remove this blocker and see what happens. The copper starts to spin in a clockwise direction and will continue to do so as long as it's conducting current and remains in that magnetic field. Alright, for the final part of the demonstration, I have reversed the polarity on the magnets sitting below the battery. So the magnetic field has swapped directions. It is now in the downward direction. Current is still flowing out this way to the right in that portion of the wire. Magnetic field is in the downward direction. Therefore, that portion of the wire wants to move away from us. And the same principles apply to the other horizontal portions of the wire. So this time the copper wire will want to spin in a counterclockwise direction. Alright, that's all I have for you today. Thank you guys for watching. Have a nice day.